Okay, class, we're gonna do an introductory lab over just general chemical handling and how to use glassware and common tools. So you're gonna turn this in as a group. That's backwards. So, glassware and chemical handling. You've got 6 questions there. And your directions are to perform the following tasks and describe your actions as you go. For example, what equipment are we using? Are we choosing the right equipment? And are we doing the steps in the correct order? And recording any mistakes or improvements we can make next time. So number 1 is to weigh 2 grams of sodium chloride, which is abbreviated NaCl, also known as table salt. So weighing solids, we're gonna have to use our balance here. And here's the sodium chloride, NaCl. It's a powdery white substance. Plug in my balance. Turn it on, and we have a protective cover here that we're gonna have to take off, remove, flip up, and this plate is removable as well. It looks pretty clean, so we don't have to do anything with that. But we do need to find something to measure our salt in. So we could use a number of different things. We could use this beaker, but it's already labeled acidified H2O, so that's not what we're doing. We could use this Petri dish, but it's commonly used to grow bacteria, so that's probably not it. But here's a nice convenient little weigh cup. I'm gonna label it sodium chloride, that way I know what's going on there. And it tells me that this cup weighs 1.4 grams. I'm gonna zero that out on the 0 button there. And now it has subtracted our cup's mass. So now we can either use a scoop if we have it, or very carefully, a little bit at a time. That's not even a gram yet. 2 grams is not that much on this scale. It's about a teaspoon. Okay, I got it right on the dot, 2.0. Let's say I overfilled it, oops, 2.3. That's fine as well. For our purposes, ask your instructor if you're ever unsure. So I'm gonna put that I used the balance. I made sure I zeroed my cup. And I'm gonna put the exact measurement that I made, which is 2.3 grams. Now, in case I accidentally overfilled it, that's 3.4 grams. That's too much. So that's a little too far away from 2. That's almost twice the amount. So I'm not gonna pour that back in here. That's called cross-contamination. I'm just gonna dispose of it in the trash. Okay, so I got my 2 grams of sodium chloride weighed out. Step 1 done. Set that to the side. Okay, and I'm done with my balance, so I can turn it off and unplug it. All done with that. Always keep your lab area clean. Only have what you need in front of you. So step 2, measure 45 milliliters of nickel sulfate. Phew, that's me. An ionic compound used in electroplating. So it's like one of those questions where you have too much information. I don't really care for this purpose that it's an ionic compound used in electroplating. That's extra information meant to distract you. I did get a few students that way. It's not to be mean, it's just to zero in on the information you use. So I might even highlight it. I need 45 milliliters of nickel sulfate. So I have a few different colors here in front of me, and they're all properly labeled. The nickel sulfate is the green solution. I might even write that. The more notes, the better when you're doing a lab. This is the green solution. Now, again, I need to measure 45 milliliters, which is a liquid volume. This is a liquid, and it's right now stored in a beaker. Okay, so this is not a measuring tool. This is just a holding tool. The best tool to use for this is the graduated cylinder. It's in a cylinder shape. It's graduated because it has little marks on it. I also have the 25 milliliter graduated cylinder, but it only goes up to 25, so it's better for smaller volumes. 45 is right in the middle of this cylinder, so remember to use your meniscus technique. You want to look at the bottom of that meniscus, the curved part of the liquid. And I don't want to get too close in case it splashes, but we're going to pour slowly because we don't want to overfill. Again, same thing. Okay, I'm getting closer to 45. I'm going to pour a little bit slower. Okay, so I have 45 on the dot, which is right in between 40 and 50 here. Again, if I accidentally overfilled, okay, now I have 50. That's too much, right? So again, ideally we would want to label this nickel sulfate so we knew it's green, so we know, but normally lab solutions are clear. So I have too much. What should I do? Definitely don't pour it back in here. That's cross-contamination again. So you could pour it in the sink if this solution can go in the sink, but let's just say it can't. Now we have to ask our instructor how to dispose of it. Okay, so today I'm just gonna pour it out in the sink because this is colored water here. Now I have 45 milliliters of my solution, and I can put that to the side. So I might make a note that I used a 100 milliliter graduated cylinder, overfilled to 52 milliliters, poured excess in drain, and then I ended up miraculously with 45 milliliters on the dot. Okay, task 2 done. Task 3, dispense, which means to spread out. Dispense 1 ml of bromothymol blue, which is a pH indicator solution. Probably going to be this blue one, but we should read it to make sure. Bromothymol blue. Dispense 1 milliliter of bromothymol blue solution into the Petri dish. So let's get rid of our nickel sulfate. We don't need that anymore. We don't need the acid yet or any of this stuff. So here's our bromothymol blue. Here's our Petri dish. The Petri dish has a top and a bottom. A few people made this mistake today. The top is more shallow than the bottom. The bottom's deeper. So it's okay if you do it on the top for today, but if you were to pour a media for bacteria in here, that would cause some issues. So know your bottom and top of the Petri dish. This is the bottom, the deeper portion. And to dispense 1 milliliter, we could use graduated cylinder, right? Because it's for volumes. This is a 25 mil, I think. 1 milliliters on here, but we would introduce some error. That's pretty far down at the graduated cylinder's capacity. So let's use a Pasteur pipette because this is a little bit more appropriate for this small volume. So this is a 1 milliliter Pasteur pipette, so it's perfect. It's also good for drops. So dispense 1 milliliter of bromothymol blue into the Petri dish. So we're going to depress the plunger outside of the solution. Suck it up until we hit the 1 ml. Now hold that pressure. And we're going to make one nice big drop there. Okay, when we're done with this, we can throw it in the trash. We don't want to reuse that. We don't want to clean it. It's disposable. All right, and now we have our 1 drop of bromothymol blue. Let's label our Petri dish. Done. Now, last hands-on activity, our salt over here, is to practice diluting acids, which needs to be done in a certain stepwise manner. Mix 1 milliliter of acid. Here's our acid. Today it might be sulfuric, it might be hydrochloric, with 50 milliliters of water. Here's our water. Where should we put it? We already have a pre-labeled beaker, a holding tank for our solution, and it says acidified H2O, which is water that has been acidified or has acid added to it. So how do I do this, right? If you remember from the notes, there's a quote to remember this, a slogan: do as you oughta, add acid to water, with the Boston accent. So we're gonna add the acid to the water. So first we need to get the water, right? I'm gonna need one more beaker here. Because I already used my other beaker for the nickel sulfate. I don't want to reuse that same beaker. I want to use one that has been dedicated for water. No cross-contamination. So try not to touch the sides when we're doing this. So I'm measuring. I need to get down there. I've already overfilled because I wasn't paying attention. So I'm not going to pour it back in there. I'm at 55. This is water. I'm going to have to pour it down the sink. All right. Now I'm at 51. That's close enough. Do as you oughta. Add the acid to the water. Water's in. I had one group today just pour their acid, and I said, well, how did you measure it? And they said, well, we just eyeballed it. No eyeballing in science. Here's a new pasture pipette, unused. I'm sure it's unused because I just got it out of the bag. Here's my acid. I'm going to verify 1 milliliter of acid. I didn't have enough. I'm going to have to try again. Okay, there we go. Have a slight bubble, but that should be okay. Now, I'm not just going to squirt it all in there. I'm going to drop wise. And in the lab, we might have a magnetic stir bar in there mixing it up while we're doing it so we don't have any pockets of concentrated acid. I'm going to drop wise add this. It's tedious, but it's worth it. We don't want a large exothermic reaction occurring. So I'm dropping it, and my water's turning slightly pink. So Miss Mays will know that you added the right solution because it'll be slightly pink. All right, we don't need to wash this out. We don't need to make any bubbles or mix it up, okay? We're done with that. We can throw this one away. So we have our acidified or acidulated water. It's our final solution that we were gonna make. So we're done with all of our lab solutions. I forgot to write down some of my observations, which you should always do at the time, but I don't have a partner here. So I did not have any issues with my bromothymol blue. I used the Petri dish and I used a pasture pipette to put my 1 ml on there. And I can say that I put it on the bottom of the dish, the deep part. That's where any of our solutions should go in a Petri dish. And 4, I just mix my acid with my water. So I need to indicate that I use the pre-labeled beaker that said, quote unquote, acidified H2O water, and drop wise added 1 milliliter of acid to 50 milliliters of water, which I measured with my 100 milliliter graduated cylinder. It's the most involved question on here. Now, the last 2 are theoretical or hypothetical questions. Number 5, identify the following symbol. This is one of our chemical hazard symbols. It's going to be backwards, but it's the one with the hands that are kind of sizzling up. That is the symbol for our corrosives. Explain the meaning. Corrosives can leave chemical burns, like acids. So we have to be extra careful with those. Okay, that's corrosive symbol. Last one. Number 6, acetone is a very powerful solvent used in paint thinner and nail polish remover. It is considered a volatile organic compound. Now, if you don't know what that is, go back and look at the back of your notes. Also called a VOC. It's under the flammables section because a lot of flammables are VOCs, or volatile, which means they're not stable. They release toxic gases, so they can hurt your respiratory system. So explain where we would handle this. Something with fumes. We don't want it out in the open. We don't want it under our nose. We're not just going to hold our nose. We have a tool for that. That is the fume hood back here. Explain where you would handle this and why. The fume hood. Because of the respiratory hazard, and your eyes too. So your lungs and your eyes, these fumes can get in there and harm them. And that is it. You should turn that into the box for Schoology. Have a good day.